CERN, the world's most advanced science research center, has always been surrounded by both wonder and fear. Known for unlocking the secrets of the universe, from finding the Higgs boson to exploring space and time itself, CERN's work is nothing short of revolutionary. But behind its groundbreaking experiments, conspiracy theories continue to grow. Some believe that the massive machines hidden deep underground are not only searching for new particles, but also risking the safety of the entire planet. The Large Hadron Collider, stretching 27 kilometers, has been accused of creating black holes, opening portals to other dimensions, or even disturbing reality itself. These claims, often fueled by fear and mystery, suggest that CERN scientists may be dealing with powers far beyond human control. While researchers insist their goal is pure science, conspiracy theorists argue that the risks are far greater than the rewards. For them, CERN is not just a place of discovery. It is a doorway to unknown dangers where every new experiment could change our reality forever. David Icke's dark warning among the loudest voices raising concern about CERN is David Icke, a man famous for his controversial views on hidden powers and global conspiracies. Icke claims that what happens deep inside CERN's underground tunnels is not simply science but something far more dangerous. According to him, the Large Hadron Collider is not just smashing particles, it is tearing at the very fabric of reality. He warns that these experiments could open gateways to other dimensions, allowing forces we do not understand to enter our world. His statements fuel fear, especially when paired with mysterious events and unexplained data coming from CERN. While mainstream scientists dismiss his claims as fantasy, his warnings spread quickly online, reaching millions who already distrust powerful institutions. For many, Icke's dark vision of CERN as a machine meddling with existence itself makes them question what scientists are really doing behind closed doors. Whether one believes him or not, his words add fuel to the growing storm of suspicion around CERN and its true purpose. Power and peril of science. CERN stands as a symbol of human ambition, where science pushes past every known boundary. The discoveries made here have transformed our understanding of the universe, proving the Higgs boson exists, revealing the hidden rules of matter, and opening new paths to knowledge once thought impossible. Yet, with great discovery comes great danger. The same machines that uncover secrets of creation also raise fears of destruction. Critics worry that the immense energy inside the Large Hadron Collider could spark disasters, from micro black holes to the collapse of reality itself. Though scientists argue these risks are close to zero, the scale of their experiments makes the public uneasy. To some, it feels as if CERN is tampering with forces too big for mankind to control. To others, it is the bold price of progress, a gamble to understand creation itself. This balance between power and peril is what makes CERN both admired and feared, a place where the future of science and the unknown dangers of ambition meet head-on. Birth of CERN in the 1950s. CERN was born in the mid-1950s, a time when the world was still healing from war and nations were racing to prove their scientific power. Europe wanted to rebuild not only its cities but also its place in global science. Out of this ambition came the European Council for Nuclear Research, CERN. It was founded as a cooperative project where countries could share knowledge, resources, and talent. From the very beginning, CERN had one bold mission: to unlock the hidden laws of the universe by studying the smallest building blocks of matter. Over time, it grew into the world's largest laboratory for particle physics, drawing thousands of scientists from across the globe. What began as a dream of unity and discovery soon became a symbol of ambition without limits. While many celebrated CERN's achievements, others grew cautious. They asked, could mankind handle the power hidden in these experiments? The seeds of both admiration and fear were planted at CERN's birth, shaping the way the world views it today. Fears of black holes and chaos. From its earliest days, CERN's experiments have stirred up fears that go far beyond normal science debates. The idea of smashing particles at near light speed excites physicists, but to outsiders it can sound terrifying. One of the most common worries is that the Large Hadron Collider could accidentally create a black hole. People imagine a tiny tear in reality that grows until it swallows the Earth. Others fear that disturbing the building blocks of the universe might unleash chaos, bending the laws of physics or opening doors to dimensions we cannot control. These dramatic scenarios spread quickly online, fueled by headlines and conspiracy videos. Scientists at CERN strongly deny these risks, explaining that even if a microscopic black hole were created, it would vanish in an instant. But fear is hard to silence. For many, CERN is no longer just a research lab. It is a place where humanity dares to play with powers it barely understands, standing on the edge of discovery and disaster at the same time. Rise of the Large Hadron Collider. The Large Hadron Collider, or LHC, is CERN's crown jewel and the machine that put it at the center of both admiration and fear. Construction began in the 1990s, and by September 2008, the colossal project came alive, stretching an incredible 27 kilometers in a circular tunnel beneath the border of France and Switzerland. The LHC is the largest and most powerful particle accelerator ever built. Its purpose is simple yet staggering. Smash protons together at near light speed to reveal the hidden rules of the universe. Thousands of scientists and engineers worked for years to bring this machine to life, using massive superconducting magnets and advanced technology to guide particles through its underground ring. The LHC quickly became a symbol of human genius, pushing science into realms once thought unreachable. Yet its sheer size, cost, and power also fueled conspiracy theories. For many, the rise of the LHC was more than science. It was humanity opening a door that might never close again. The 45 billion supermachine, the Large Hadron Collider, did not come cheap. With a staggering price tag of over $45 billion, it stands as one of the most expensive scientific projects in history. Supporters argue that the cost is justified, pointing to the revolutionary discoveries it has already produced, like the confirmation of the Higgs boson and glimpses of physics beyond the standard model. They say that unlocking the universe's deepest mysteries is worth any price. But critics question if so much money should be spent on smashing particles while the world faces poverty, climate change, and crises closer to home. To them, the LHC is a symbol of misplaced priorities, a giant underground ring consuming resources while offering only theories in return. Still, the machine's scale and complexity inspire awe. Thousands of scientists, engineers, and institutions from over 100 countries joined forces to make it possible. Whether seen as a waste or a wonder, the 45 billion supermachine defines modern science: ambitious, powerful, and impossible to ignore. Particles at near light speed. Inside the tunnels of the Large Hadron Collider, particles are pushed to speeds almost equal to light itself, guided by superconducting magnets nearly 1,000 times stronger than Earth's magnetic field. Protons and ions race around the 27-kilometer ring more than 11,000 times per second. This astonishing feat of engineering allows scientists to recreate conditions similar to the birth of the universe moments after the Big Bang. When these ultra-fast particles collide head-on, the impact releases a burst of energy and produces new particles, many of which exist for only a fraction of a second. Specialized detectors surrounding the collision points capture every trace of these fleeting events, creating a massive flood of data for researchers to study. To the scientific world, these collisions are keys to unlocking hidden laws of nature. But to conspiracy theorists, accelerating particles to such unimaginable speeds feels reckless, as if humanity is tampering with forces that could spiral out of control. Data flood beyond imagination. Every collision inside the Large Hadron Collider produces a storm of information. Tiny particles appear and vanish in less than a heartbeat, but the detectors record their traces in incredible detail. This creates a tidal wave of data, over 15 petabytes every year. To picture it, that's equal to hundreds of thousands of movies stored annually. By 2017, CERN had already stored more than 200 petabytes, a digital library larger than anything most people can imagine. Sorting through this mountain of information is a challenge as great as building the collider itself. Teams of scientists spend years analyzing fragments of collisions, searching for rare signals hidden in the noise. Each discovery depends on spotting patterns so small they could easily be lost. Yet, this endless stream of data also fuels suspicion. Conspiracy theorists ask what secrets might be buried in those files. Are scientists telling us everything they see, or are some discoveries too dangerous to reveal? The flood of data only deepens the mystery. The Quark puzzle shocks science. Among the billions of collisions studied at CERN, one strange result caught scientists by surprise. It involved beauty quarks, tiny particles that exist for only a fraction of a second before decaying into lighter particles. According to the standard model of physics, these quarks should break down evenly, half the time into electrons and half the time into muons. But the data told a different story. Instead of a 50-50 split, beauty quarks were transforming into muons nearly 70% of the time. This imbalance made no sense under the existing rules of physics. It suggested the presence of something new, perhaps an undiscovered particle influencing the outcome. For researchers, it was like finding an extra piece that didn't fit into a completed puzzle. If confirmed, this could mean the standard model, the foundation of modern physics, is incomplete. For conspiracy theorists, the anomaly fed darker fears that CERN's experiments were opening doors to forces unknown, rewriting the laws of reality itself. Cracks in the standard model. The standard model of physics has long been the blueprint for how the universe works. It explains the behavior of particles and the three main forces: electromagnetism, the strong force, and the weak force, with stunning accuracy. Yet, it leaves out some of the biggest mysteries: gravity, dark matter, and dark energy. That is why every odd result at CERN sparks such intense debate. When the beauty quark behaved differently than expected, many scientists began to wonder if the standard model is finally showing its limits. Could there be an unknown force or hidden particle at work? If so, the framework that has guided physics for decades may need rewriting. For researchers, this is thrilling, a chance to uncover the next layer of reality. But for skeptics, these cracks suggest danger. Experiments at CERN might be pulling on threads that hold the universe together. Whether exciting or frightening, the cracks in the standard model point to discoveries that could change everything. A new force called Z prime. As scientists dug deeper into the strange beauty quark results, a bold idea began to take shape. What if a new, hidden force was influencing the particles? They named it Z prime, a possible carrier of interactions never seen before. Unlike the well-known forces, gravity, electromagnetism, strong and weak, this new force might act differently on electrons and muons, explaining the imbalance. If proven, Z prime would shake the very foundations of physics, opening doors to answers about dark matter, the Higgs field, and even the unification of forces. For physicists, the possibility is electrifying. Yet, for conspiracy theorists, it sounds like proof that CERN is tampering with powers beyond control. Could this new force be harmless, or could it unlock something far more dangerous? While researchers carefully test the evidence, speculation spreads across the world. Z prime stands as both a scientific dream and a fearful mystery, hinting that the universe may still hold secrets beyond imagination. Elon Musk on CERN's power. Even Elon Musk, known for his bold visions of space travel and technology, has spoken about CERN and the scale of its power. He described the Large Hadron Collider as the most powerful particle accelerator ever built, a machine capable of smashing protons with energies once thought impossible. Musk pointed out how more than 10,000 scientists, labs, and institutions from over 100 countries joined forces to create this underground giant. The first collisions reached 3.5 tera-electron volts per beam, and later upgrades pushed the energy to 6.5 TeV, setting records in physics. To Musk, the LHC is proof of human ambition at its peak, an achievement as impressive as landing rockets or exploring Mars. But his comments also reminded people of the risks, as such power always comes with questions. Could the same machine that revealed the Higgs boson also unlock forces that we are not ready to control? Musk's words add to the mix of awe and unease surrounding CERN's true potential. Chasing the Higgs boson, at the heart of CERN's mission, was the hunt for the Higgs boson, a particle first proposed in 1964 but not confirmed until nearly 50 years later. Nicknamed the God particle, the Higgs was believed to be the key to explaining why matter has mass. For decades, it remained elusive, as no experiment could produce or detect it. That changed with the Large Hadron Collider, designed specifically to probe the deepest layers of particle physics. By smashing protons at extreme energies, scientists created rare conditions where the Higgs could briefly appear before decaying into other particles. In 2012, two teams at CERN, ENOS and CMS, finally announced proof of its existence, a moment celebrated as one of the greatest scientific achievements of modern history. But the discovery was not the end. It raised new questions. How stable is the Higgs field? Could there be multiple types of Higgs bosons? For researchers, chasing the Higgs is still ongoing, promising answers that may redefine the universe itself. The God particle debate. The Higgs boson earned the nickname, the God particle, but the title was never meant to be divine. In fact, physicist Leon Lederman jokingly called it the goddamn particle because it was so difficult to find. Publishers shortened it to God particle for his book, and the name stuck, fueling media hype and sparking controversy. Many scientists disliked the nickname, arguing it misled the public by mixing science with religion. Despite the name, the Higgs boson is not about faith. It's about physics. It explains why particles have mass, a mystery that puzzled scientists for decades. Without it, atoms wouldn't exist, stars wouldn't form, and life as we know it would be impossible. The debate over the name reflects a deeper issue: how science is communicated and how public fears or fantasies can shape perception. To some, the God particle sounds like humanity is playing creator. For others, it's just a dramatic label for one of nature's most important discoveries. Higgs and the mystery of mass. The Higgs boson isn't just another particle, it's the missing link in understanding why anything in the universe has mass. Scientists believe that all matter interacts with an invisible energy field called the Higgs field, which fills all of space. As particles move through this field, they gain mass, just like a person moving through water feels resistance. Without the Higgs field, everything would fly around at the speed of light, never forming atoms, stars, or even us. This concept changed how we think about reality. The discovery of the Higgs boson in 2012 was proof that the field exists, but the mystery isn't solved yet. Physicists still don't fully understand how the field works or why the Higgs boson has the mass it does. Even stranger, some theories suggest the Higgs field might be unstable, meaning the universe could one day collapse. While that sounds terrifying, scientists say such a collapse would take longer than the age of the universe. Still, the mystery of mass keeps researchers searching for deeper answers. Could the vacuum collapse? One of the strangest questions raised by the Higgs boson is whether the universe itself is stable. Scientists discovered that the Higgs field, an invisible energy field filling all of space, has a constant energy built into it. This energy helps shape what we call the physical vacuum, the state of empty space. But here's the problem: some calculations suggest this vacuum might not be truly stable. Instead, it could be metastable, meaning it only looks stable now but could collapse at any time due to a sudden quantum shift. If that ever happened, the universe would change in an instant, rewriting the laws of physics everywhere. Thankfully, researchers agree this is extremely unlikely to happen anytime soon. The time scale for such an event is trillions of years, far beyond our worries. Still, the fact that it's even possible shows how much we don't fully understand. Could experiments at CERN influence this vacuum? Scientists say no, but conspiracy theorists aren't convinced. The question lingers: how solid is the ground we stand on? Antimatter demon or discovery? Antimatter sounds like science fiction, but it's very real and deeply mysterious. At CERN, scientists study antimatter to understand how the universe began. Antimatter is made of particles that are like opposites of normal matter. For example, an electron has a negative charge, but its antimatter twin, the positron, has a positive charge. When matter and antimatter meet, they destroy each other in a burst of pure energy. This powerful reaction has sparked wild theories and fears. Some say CERN is trying to harness a force too dangerous to control. Others claim antimatter could be used as a weapon or even open gateways to other realms. A now infamous conspiracy suggested CERN was summoning demons using antimatter, fueled by a leaked video of a supposed ritual on site. CERN dismissed the footage as a prank, but the story spread fast. In truth, antimatter holds great promise for science, helping us study the Big Bang, gravity, and the differences between matter and antimatter. It's not demonic, it's discovery. The Mandela effect and CERN. The Mandela effect is a strange phenomenon where large groups of people remember events differently from how they actually happened. Some recall the Berenstain Bears spelled as Berenstein, or believe Nelson Mandela died in prison years before he actually passed. These memory mismatches have puzzled many and sparked a theory: what if our reality has somehow changed? That's where CERN enters the conversation. Some conspiracy theorists believe that CERN's high-energy experiments may have disturbed the fabric of reality itself, shifting timelines or creating alternate dimensions. They claim the Large Hadron Collider might be causing tiny rips in space-time, merging or reshaping parts of our world without us knowing. Scientists at CERN strongly deny these claims, explaining that the energy levels in their experiments are far too small to create such effects. Still, the mystery of the Mandela effect continues to capture imaginations worldwide. Whether it's psychology, collective false memory, or something stranger, many people now link it, right or wrong, to the powerful machines buried deep beneath CERN. Claims of rituals at the lab in 2016, a disturbing video surfaced online that sent shockwaves through the internet. It showed hooded figures performing what looked like a dark ritual in front of the Shiva statue at CERN's Geneva facility. One of them appearing to stab a woman. The grainy night vision footage was eerie and mysterious, fueling a wave of conspiracy theories. Some claimed it was proof that secret occult rituals were being performed at the world's most powerful scientific lab. Was CERN hiding a dark agenda behind its experiments? The truth, however, was far less dramatic. CERN quickly responded, stating the video was a prank staged by employees without permission. No real harm occurred, and the victim was never identified because it was all an act. Still, the damage was done. For conspiracy theorists, this incident confirmed their worst fears. Even if the ritual was fake, it left people asking deeper questions. Why would scientists at such a serious place stage such a scene? Was it a joke, or a glimpse into something real? Ghost particles. Neutrino hunt. Neutrinos are some of the strangest and most mysterious particles in the universe. Often called ghost particles, they pass through almost everything. Billions are moving through your body right now without leaving a trace. These tiny particles have almost no mass and carry no electric charge, making them extremely hard to detect. But scientists at CERN are determined to track them down. In a major breakthrough, The Forward Search experiment at the Large Hadron Collider detected high-energy neutrinos created by a particle collider for the first time ever. A total of 153 interactions were observed, proving that even these ghostly particles can be caught with the right tools. Neutrinos are thought to hold secrets about the early universe, stellar explosions, and even dark matter. They can travel through stars and planets, offering a new way to study deep space. For physicists, finding them is like unlocking a hidden layer of reality. For the world, it's another reminder that the universe is still full of invisible wonders waiting to be discovered. What will CERN find next? As CERN continues to push the limits of science, one question remains on everyone's mind: what will they discover next? From the Higgs boson to ghost-like neutrinos, each breakthrough has changed how we understand the universe. But scientists believe they've only scratched the surface. With new upgrades to the Large Hadron Collider, including the upcoming high luminosity phase by 2029, CERN will soon generate more collisions than ever before. This means more data, more chances to spot rare particles, and more opportunities to challenge the law. Researchers hope to find signs of dark matter, explore the true nature of time and space, and maybe even uncover new forces or particles that rewrite the standard model entirely. Yet for many outside the lab, these bold pursuits also raise deep fears. What if the next discovery goes too far? As excitement builds, so does curiosity and caution. Whether a doorway to truth or danger, CERN's future is racing toward the unknown, and the world is watching.